Okay, so we've talked about how soil resources are one of the very most important parts of how we need to be able to sustain agriculture in 2050 and beyond. But I'm going to go into a little bit more detail of why that is. So we have to look at how desirable, or in some cases less desirable, our land could be and will be in the next couple decades. So most of the soil that we use for crops is already in use, has been in use for over 100 years in America, couple hundred years in America. So very important when you in terms of how we've been utilizing the same ground for over hundreds of years. The less desirable land that we have is good, and we need that land, but it's going to require a lot more inputs and it's going to give out lower yields. So for example, if I have 50 acres of pretty clay soil, I need to make sure that I am utilizing that clay soil, not putting in a crop that's not going to grow well in clay soil. That clay soil is also going to need some more input, so more fertilizer, more spray. A lot of noxious weeds are able to grow pretty well in clay soil, so it's going to require a lot more inputs when we look at those soil resources. And then I love soil, and I'm a conventional grower. My husband and I are, but unfortunately soils are being degraded by agriculture and urbanization. So people are buying land, acres, even if it's just a couple acres. They're buying acres of land just outside of town, but they're buying it for a good price, and sometimes that price is pretty hard for that landowner to refuse. So it's being degraded because people want to build on it. They don't want to be outside of town too much. They want to be 10 minutes away from Walmart, but they don't want to live in the big city. So that's another way. Also, 5 million, so about 12 million acres, 5 million hectaacres, so about 12 million acres of cropland is being lost annually because of things like urbanization, because we have more people on the planet that are living longer. They might want to have a house in two different states, their winter home and their summer home. And, we do need some long-term preservation of agricultural lands. And unfortunately, our political system is pretty hard to do that. It's pretty hard to limit that urbanization so that agricultural lands won't be affected by that. We agriculturalists are the largest users of water. About 70% of the world's water goes to some form of agriculture, whether that's growing food, whether that's giving livestock water, about 70% of that. So more than then on the other side of that, more than 1 billion people lack the clean drinking water that they should have. So we are the largest users. Agriculture is 70%, and more than 1 billion people lack access to clean drinking water, which is astounding. And in some cases, it's very sad when you look at that. So how do we fix that? How does agriculture, how do we sustain that? How do we make sure that, or how do we decrease that 70% number and increase the amount of drinking water that more people have and they deserve that clean drinking water? That's a problem, and that's a solution that our generation is going to have to come up with, and it's going to have to be pretty quick. So, and then on the other spectrum of that, agriculture water may someday compete for water for direct consumption. So that's a big thing too. A big unsustainable water that is a pretty big concern, so it's not like always flowing in that water source, is the Ogallala Aquifer. We're going to talk about that in class, and how a lot of, there's definitely two sides to every story, and there's definitely two sides to this aquifer and how it should be used. So you're going to get to look at the different aspects of this aquifer and other aquifers, and how agriculture uses it and how it is used by people. Something that no one really saw coming in 1960s, the 1960s, you would have predicted something like this, and people would have laughed at you because they never really realized the impact that this energy boom would have given to the world. So, one of the most interesting facts to me about energy is we increase about 2% per year worldwide on energy. So that's everything from automobiles, that's everything from technology, anything that's using energy, we increase that about 2% every year. And that number will probably climb. It's not going to decline. It will definitely increase in these next 30 years or so. Also, non-renewable sources, they supply 85, almost 90% of the energy that's consumed. So that's non-renewable. So that's not things that we're able to pull from different places. And then agriculture has a pretty intense or pretty huge sustainability of fossil fuels that can be converted to renewable energy. But some would argue that we're going to run out of those fossil fuels and we're going to use them up way sooner than anybody else ever predicted. Another interesting fact is that energy is accounted for approximately 15, it's actually closer to 20% of the agriculture's production costs. Okay, so when you look at a farmer or a rancher's cost analysis, or when they're when they're doing their taxes, they could pull off all of the energy that they use, whether that's the energy from a grain bin or anything helping to utilize their tractors more efficiently, anything like that. The energy that they're using, about 15 to 20%, in some cases could be more of that production costs is going to be energy. Some of that can be wrote off of your taxes, some cannot. You're going to tell me, well, Allison, this was way back in 2002. I'm using this because a lot of this really hasn't changed. A lot of these numbers really haven't changed. So if you're looking at the source, again, we're talking about energy. You're looking at the source. So like fertilizers, diesel, electricity, gasoline, pesticides, propane, natural gas. If you look, what is going to be pretty high up there, or the highest, is fertilizers. Why? Because we're always using fertilizers, and this is something that's very, very important to crop production. And this is including organic fertilizers. So this isn't just conventional fertilizers. This is everything. About 29% of the total U.S. farm energy is used by fertilizers. Diesel's about 27, a little over 27. Electricity's 20.7, and then you go down to natural gas, 3.6, just because we're using a heck of a lot more of diesel and other sources of energy for that. So pesticides, a lot smaller than you might think because fertilizers are so much, but pesticides about 6.3. I don't anticipate that going up any higher than 8 or 9, but that's just my opinion in the next 30 years. That is a way for us to measure how much water you use, one person uses, and how much you're able to absorb its waste. So how that combined land, how much the water resources that you use, we're going to look at that as a whole, as a human population, how it's going to absorb its waste. This week in class, we're going to look at your ecological footprint and how if you are very efficient in what you use, like the land, the water, the resources, the food that you use, or maybe you're not as efficient with that. So we're going to look at that. One big thing that is just always shocking for me is the United States has a much larger ecological footprint than most other countries. We'll probably be number one in that. We pay the lesser amount of food, so our country pays very little for food, and that is pretty. You could see that on a daily basis if you go to McDonald's and you order off the dollar menu. You won't find a dollar menu in sub-Saharan Africa. That's just not a thing. So we are the country that pays the less amount of money for food, but we have the largest ecological footprint, and that's astonishing. So, and then also the present of human population of the ecological footprint that will then increase or go just blow the world's carrying capacity out of the water by 25%. So 25% of the ecological footprint will, I mean, the human population is just going to blow it out of the water in the next 30 years. So just absolutely astonishing when you look at footprint. And a lot of factors that use environmental resources. We're also going to look at this in class this week, so make sure that you really read about it in your book. You also have a question, I believe, in your assessment this week as well. So this is the IPAT, not the iPad, and this is not an Apple anything having to do with Apple equation. I had a student ask me that last semester. It has nothing to do with Apple or that company or anything like that. This is just an equation that we look at to assess a lot of different factors with environmental resources. So let's just look through this real quick. So I equals P times A times T. Okay, so just a little bit of math here. We'll call it cowboy math, farmer math. I is the environmental impact of resources used and waste generated. So how much resources you use and how much waste you generate. Okay, so that is going to equal P, which is the size of the human population. So the size of the human population right now, and we can get that, well, it's actually climbing every day, so we will get that number the day that we do this in class. A is the level of consumption by that population, which that's a given number. I will give you that number because that's a USDA given number. And then T, the technology that we obtain those resources from to transform them to useful goods and wastes. So how we are taking all of this technology and not just wasting it, how we're actually turning it into useful goods and being able to utilize the waste as well. Improving production around the world. It's all about improving production, in developing countries. So those countries that have low per capita income, those countries that have, they're living on $1 to $2, sometimes even less than that a day. So how do we do that? How are we figuring out how to do that? We are breeding new crop varieties that can be able, these farmers and ranchers throughout the entire world are going to be able to sustain and grow in their areas. And then we're going to throw in some technology. So we're able to take technology that used to cost, a GPS for a tractor, let's say a 4955 John Deere tractor 20 years ago, everybody would have thought it would have cost $200,000. Now it costs about 10. So we're able to utilize gradients for this green revolution. It's just awesome that we have these different ways of giving people the opportunity to grow food in different parts of the world. This is also credited with increasing worldwide yields of cereal grains and other crops. I mean, you would have never thought that you could grow field crops in Africa or in some parts of Russia, but that's happening now because of this green revolution. And then also, although there's a lot of countries that have benefited, there are some that are not. So a lot of areas that have a very sandy climate and a dry climate where they're not able to even access water in hundreds of miles, they're not really benefiting from that because you can't really grow a lot of things in sand. And if you don't have water, if you don't have some sort of irrigation system, that's not going to work. So unfortunately, we haven't hit every one of these countries and continents, but it hopefully will happen soon. In Africa. Africa is pretty special in terms of how we view people that are living and trying to develop that country. But this is a pretty cool partnership that different countries like the United States help a lot of small scale farmers throughout that large continent of Africa. And so a lot of really awesome ag companies like Monsanto, Bayer, which that's apparently going to be Bayer now because I think Bayer just bought Monsanto. But a lot of these big ag companies are giving millions of dollars to partner with small scale farmers to help them in this green revolution. There's been a huge practical solution boost of productivity and incomes in these developing countries because Other countries are able to give a lot more to them because we're doubling and tripling yields in our own country, so we should be helping out these other countries as well. So the goal within 20 years or by 2050 is to double or triple the yields that we have in Africa, and that's going to reduce hunger. It's going to reduce the poverty level across Africa, which is so important when you look at the global food crisis that we have today. The way we grow food, absolutely vital. We have to have them. They are trained scientists that are going to give the American farmer or rancher the just insight on how we are growing different crops in different areas of the world. And it's so important to see that, and it's so important to help that in my opinion. So these are in tropical region specific institutes that really focus on just improving that local economy and most importantly that local agriculture and their production techniques as well. They also are really, really big in genetic diversity, so how we're going to be able to maintain seed banks, and we'll talk about that in class this week. Seed banks are obviously very, very important to the world economy and very important to the world ag production as well. So, wrapping all this up, how are we going to feed this world in 2050? How are we going to feed this world? One of the most important aspects of this chapter, and what I really want you to get from this, is that we have got to protect existing lands that we have to grow crops and to raise livestock production in the United States and in the world. That is so important. We have to practice water conservation. You know, the USDA has given us so many opportunities, especially young farmers opportunities, to conserve that water, to make waterways, to put in sustainable or more efficient waterers for livestock. It's so important. We need to expand different approaches to crop production. You know, this younger generation is really the pioneers of utilizing technology in crop production. That just needs to push forward a lot more. We need to continue plant breeding, whether that's on a conventional basis, whether that's on a organic basis, whatever that is, need to continue that. We have to preserve genetic diversity, and we have to look at renewable energy sources for agriculture and how we're going to sustain that in 2050. So I'm really excited for this week's lecture. It is something that I'm so passionate about, and I hope you all get so much from it. And get ready. It's going to be fun. It's going to be something that we will not be sitting in our chairs a whole lot, and you're going to really understand and see a lot more of the world's food problem that we have today and how we're going to feed this world in 2050.